Hi, good afternoon, everyone. So today we will be continuing hosting the ACM training session. So my name is Rayson. So as we continue from last week, this week we're going to discuss a question about the barn repair. Let me screen share this. Okay. So yep. So this is the question about. As last week totally have discussed, barn repair is actually quite a easy problem. It just the story is about when there is a dark and stormy night, and then they have rid off the gate and then the store, so they need to like rebuild the stores all over again to keep the count to be inside the store and not running out. So the problem given here is that the M will be the maximum number of board that can be purchased from the provider. It just this board is used to closing the stores to prevent the cow to be running away. So this is a maximum number of bots that you can purchase of to closing the store itself. So the S will be the number of stores that given the farm size is the total number of store available actually. So the C will be the count, the number of count that were inside the store. So yep, so this is it. So we need to calculate the wait so yeah, we need to calculate the minimum number of stores that must be blocked in order to block all the stores that still have account in them. So we need to find the minimum number of stores that need to be closed down in order to block all the stores that have count inside. So basically the concept of doing this is that like this. So given the input sample input is like this. They were giving us an M, and then this one is the C, this one is the S, this one is the source, and this one will be the count. So this is the maximum number of board that we can bought from the provider, and then this is the maximum store that in the barn, and then this will be the number of count that in the store itself. So after these three input will be inserted, there will be have a series of input to tell you where is the count location to be at. So below are the representation of the data that I will be using later on to represent the data that the certain store that we have a count inside there. So the 0 will represent the stores that we don't account. So the overall array representation will be like this. So yep. So later on, the concept of my solution is quite simple actually. My concept of solution is just about calculating the biggest gap between in this array. I will calculate the biggest gap and then push down to a priority queue and then plot it out with the m-1 of the board given. The board is right. The total number of board is 4. So the gap that I need to produce is actually 3. So the gap will be something like this. The 4 will be the n, and then -1 will be equal to 3. So I will perform like the popping out the maximum gap. I mean the maximum gap here. Without the count in the store, I will pop up around 3 times to get the minimum number of stores that will be blocked. So basically a calculation will be like this. So now we'll be showing like the code. So basically this one is the data structure, the class for the barn, and this one is keeping the gap. We have 3 variables here, which is the start, end, and the gap. The start end is actually indicating the index of this. For example, this one is 18, right? This one is without the count. Let me take here. This one is easier. Like 4 to 6, the number 5 is missing. So this one I will push into the priority queue that indicating that start from 4 to 6, there will have 1 gap between them. So this one is the data structure that I'm using. So they will store a start, end, and the gap itself. So the comparator we'll be using is a compare between the gap to arrange the priority queue itself. So the highest gap will be at the top of the priority queue, and the lowest gap will be at the end of the priority queue. So let's continue. So this one will be like the input of board, and then stores, and then number of count. And then we will be, just taking in the count locations, and then indicate the count, the store, the count location will be equal to 1, then push back to the data structure, then we sort it. Because actually this question, right, is quite tricky in the sense that for the data set given here, it shows that it is sorted. However, it's not, in some test case is not sorted. So we can't assume the input is all sorted all the time. So we need to do a sorting again. So in here we're using the C++ algorithm, the library, which is using a sort to sort the vector. Then the begin will be here, and then this one basically is getting the size of the array itself. So then after that, I need to, because of my data structure represent here, it starts from 0. So it's like 0, 0, 1. So actually the starting is here to the end. So I need something to indicate that it start, because this 2 is not considered as a gap of the question. So I need to eliminate them. So I use a boolean, indicate that starting is whether starting or not. So yeah. So the end location and the start location, this one basically indicating the final solution. This one is a variable they're using. So now I will pushing all the gap. I will calculate all the gap here, which is like this, 4 to 6, the one gap here. I will scan through all the array, like this data set, right? I will scan through the whole data set to push in all the gap into the priority queue of PQ. So then after that, I will perform, as I said just now, I will perform the chopping of the gap. So it's something like using a formula like this. If I have a 4 board. 4 board is given, so I need like only 3 chopping times that I need to chop to produce 4 gap. So something like this. So I just board -1 to perform the pop up 3 times and calculate the total number of the gap that produced. Means that for this question, right, we can notice that the biggest gap will be between it here. Will be at here, We will have 8, right? This one, the gap between the 31 to 40, we will be having a gap here. We'll be having a gap of 8. So this one will be a first part of the array that will be chopped off. Then I will pull up this one. This will be another gap. Nope. Wait. So this one will be another gap that will be being chopped off. Like according to this, the method that I introduction just now, the total will be a number of gap that add up. Like for example, this one, 8 plus 7, and then plus another one, which is maybe 5 or 4, something like that. So it will pop it up and calculate the total number of gap of the time being chopped down. Then the final answer will be using the stores given, means the total number of store given, to minus the total minus the begin one. The begin will be the starting of the array itself. This one, the starting, because I need to know where does it start and the ending point. So it's like indicating the starting and ending. So and then stores minus the ending, something like that. The total will be the total number of the gap itself, because I need to calculate how many the count is in there, how many store the count is in there, and then the total number of the gap that I need to cut off. So it's like the total number of store minus the total number of the gap, which means we should be eliminating. Then the beginning and the ending will be indicating the overall the gap that we're not closing. So we just print out the answer. But then we need to confirm one more question, the situation, which is the board number is less than the n. Then we will run this code. Because sometimes the board, right, for example, for this question, right, if the board given is like 18, not for example 20, the board given is 20, but then the count locate, the total number of count here is only 18. So we can maximize our board. We just use 18 board to cover all the, to close all the stores, then okay already. So we don't need to like really finding the gap and everything. So if the board is more than the count that in the store, so we just take the end of this, then this one will be the solution. So yeah, so the question will be like this. So if you want, let me try to submit again to see whether this solution working or not. So hold on. Yep, bound one. So choose bound one. Okay. Yep. So it's work, and the timing is quite okay as well. So this will be it. So thanks for watching.